We want to raise the number x to a power n, for example, 2 to the 10th, which is 1024. The slow way multiplies x by itself n times. The clever way, called fast exponentiation, uses a neat fact about powers to cut the work down dramatically, from n steps to only about log n steps. Here is the insight. To compute x to the n, first compute x to the half of n just once and call it half. If n is even, then x to the n is exactly half times half, because 2 halves add up to n. If n is odd, we are missing one factor of x, so it is half times x. The important part is that we solve the half power a single time and reuse it instead of 2 separate calls. The power keeps halving, n, then n over 2, then a quarter until it reaches 0, where x to the 0 is 1, our base case. Because n halves each time, we reach 0 in about log n steps, so it terminates quickly. If n is 0, any number to the 0 is 1, so we return 1. That is the base case. Otherwise, we compute the power for n divided by 2 once and store it in half. If n is even, the answer is half times half. If n is odd, we multiply in 1 extra x, giving half times x. Let's build the fast power and try a few bases and exponents. The base case. Any number raised to the 0 is 1, and that stops the recursion. Compute the power for half of n just once, and reuse it so we do not do double the work. If n is even, the answer is half squared. If n is odd, we multiply in 1 more x. Now let's test it and hit run. There we go. 2 to the 10th is 1024, 3 to the 4th is 81, and anything to the 0 is 1. And it got there in only a handful of steps. The flow branch is near the end. If n is 0, return 1. Otherwise, compute half, the power for n over 2. If n is even, return half times half. If n is odd, return half times x. Because n is halved on every call, the number of calls is about log n rather than n. So the time is order log n, a huge saving over the naive method. The space is also order log n, the depth of the recursion stack. Remember these. First, and most important, compute the half power a single time and store it, because calling power twice would throw away the whole speed advantage. Second, split into even and odd cases using n modulo 2, adding an extra x only when n is odd. And third, for a negative exponent, the answer is 1 divided by x to the positive power, which you can handle as a special case.